So number 8 is saying the first three terms of an arithmetic progression are 25, 4p minus 1, and 13 minus p, where p is a constant. Find the value of the 10th term of the progression, right? And we're told that it's an AP in arithmetic progression. And with APs, there is what we call a common difference, which is the same for all consecutive terms, which is the difference between consecutive terms, and it is constant, meaning it's the same. So we know that this one is the first term and this one is the second term, and 13 minus p is our third term. So we know if we say the second term minus the first term, we should get the same difference as saying 13 minus p minus 4p minus 1. So if we say 4p minus 1 minus 25, second term minus first, we should get the same difference as saying 13 minus p, which is the third term, minus the second term, 4p minus 1, right? And this will be 4p minus 26 is equals to 13 minus p minus 4p plus 1. And simplifying this, we get 4p minus 26 equals 14. 13 plus 1 is 14 minus 5p, right? And collecting like terms, we'll get this 5p to the other side, and this gives us 9p is equals to 14 plus 26, which is 40. And dividing by 9 both sides, we get p to be 40 over 9, right? And with this value of p, we will safely say the first term is 25 and the second is 4 times 40 over 9 minus 1, and the third, so this is the first, the second, and the third will be 13 minus 40 over 9. These are the terms we have, and if we are to get the actual numbers, it's 4 40 over 9 minus 1, that's 25. Then this is 16 and 7 over 9, and this one will be 13 minus 40 over 9. 13 minus 40 over 9, that's 8 and 5 over 9. And the common difference, D, will be 16 and 7 over 9 minus 25. It's minus 8 and 2 over 9. We should be the same when we say 8 and 5 over 9 minus 16 and 7 over 9. We still get minus 8 and 2 over 9, meaning our calculation is correct. So we only need 1. And for us to get the 10th term, we will use this formula, which says 10th term, so it's T10 is equals to A plus N minus 1 D. And since N is 10, we will say A, which is our 25, plus N minus 1, that's 10 minus 1, 9, and D is minus 8 and 2 over 9, like this. And this gives us 25 plus 9 minus 8 and 2 over 9, which gives us minus 49 as our 10th term. So minus 49 is our answer for 8 part A. Then you get your 4 marks, right? So then we move on to part B, which says the first three terms of a geometric progression are 25, 4q minus 1, and 13 minus q, where q is a positive constant, meaning it's a positive number. Find the sum to infinity of the progression. So they've changed it slightly from the first one, which was AP. This one is now GP, geometric progression. And we know that with geometric progressions we have common ratios, which we refer to as R, which is also constant, so it means it's the same. If we say the second term over the first term, it should be equal to the third term over the second term. That's how we get the ratios. So with this we have to say 4q minus 1 over 25 should give us the same result as saying 13 minus q over 4q minus 1, right? So simplifying this, we are going to cross multiply, right? So that will be 4q minus 1 squared is equals to 25 13 minus q, right? And expanding this will be 16q squared minus 8q plus 1 is equals to 25 times 13. That's 325 minus 25q, right? And taking everything to the left hand side, that will be 16q squared minus 8q plus 25. That's 17q. Then 1 minus 325, that's minus 324 is equals to 0. And we're going to be using our quadratic formula, so that will be minus 17 plus or minus square root of 17 squared minus 4a, which is 16, and c, which is minus 324, all over 2a, which is 2 times 16. And if we punch this in our calculators, we'll get minus 17 plus square root of 17 squared minus 4a minus 324 as our c over 216, and that gives us 4, or if we say minus 17 minus square root of 17 squared minus 4 times 16 times minus 324, we get minus 5 and 1 over 16. But since the question said q is a positive constant, we're going to go with 4, which is positive. So our q is 4, and that's our answer for 8 part B. Oops, no, the question says find the sum to infinity. So now that we have our q, we still need to find our r for us to be able to find the sum to infinity. So we are taking one of these, so we can take 4q minus 1, that's 4 times 4, 16, minus 1, which is 15 over 25. So r is 15 over 25, that's 3 over 5, right? And we know that for our sum to infinity is a over 1 minus r, right? And a is 25, so it's 25 over 1 minus 3 over 5, and that should give us is 25 over 2 over 5. That should give us 62 and half. And 62,5 is our sum to infinity, and that's the answer for 8 part B, right?